So let us start. X-rays. How to produce X-rays? It is produced by X-ray tube. Its actual name is Coolidge tube. Start writing, start writing. Now only write. Coolidge tube. How does it look? Let me explain. So there will be a filament here, tungsten filament. Tungsten because it has a high melting point. So we don't want the material to melt the moment it is little hot, right? And using some low tension battery. Low tension battery means low voltage battery. We will pass current I. This I is quite important for us. So we will call this I filament current. Filament current. Okay. Now what this current will do? It will heat your filament, and as your filament gets hot, electrons will be emitted. That is called what emission? So electrons will be emitted from here by thermionic emission. However, these electrons will not have that much speed because most of the energy will go to overcome the work function. So what I want to do, I want to give these electrons some kinetic energy. I want these electrons to move fast. So what I will do, I will apply a voltage. Okay, so we will put here some, this is your anode and this is your cathode. So we will connect the anode to positive potential, higher potential. Okay. So what will these electrons experience? They will experience a electrostatic force. So because of this potential difference, these electrons will get accelerated and they will come out with some kinetic energy K. Who gave this kinetic energy to these electrons? The accelerating voltage. So this V is also very important for us. Some people call this tube voltage or accelerating voltage. What is the relation between this kinetic energy and this voltage? Here, the kinetic energy is approximately 0, I told. Right? They just come out and they don't have that much speed. But when they come out from this anode, they will be accelerated by the battery's voltage. Why? Because voltage will create electric field this way. This is plus, this is minus. So electric field is from plus to minus. If electric field is this side, force on the electrons will be this side because electrons are negatively charged. So because of that force, some work will be done and therefore there will be gain in kinetic energy, right? Okay. Then these fast moving electrons will now be allowed to fall on a target. This is your target. This target should have high atomic number. Try to remember that. So as these electrons will strike this target, this heavy metal, they will lose their kinetic energy. They will be stopped inside. Now, where that energy will go? It will go in some other form. You will see that some percentage of that energy will go, obviously go as heat and all. Heat matlab infrared. But some of this kinetic energy, if it is fast enough, if the kinetic energy is high enough, you will see this will emit photons, radiations whose frequencies is even more than ultraviolet. And if frequencies are more than ultraviolet, we call them what? X-rays. So this is how X-rays are emitted by this X-ray tube. This whole thing will be put in some tube so that you can remove the air. You don't want air molecules to disturb the electrons, isn't it? Now, what will be the relation between this kinetic energy and this voltage? The kinetic energy gained by the electrons must be equals to Q into V. Why? Because from first PU, work done is equals to change in kinetic energy. Potential difference is work done per unit charge. So what will be work done? Cross multiply charge into potential difference. What is the change in kinetic energy? K minus 0, because initially it was approximately having 0 kinetic energy, and by the time it comes out it has kinetic energy K. So kinetic energy gained will be Q into V. For electron we will write E. Don't write the sign because kinetic energy should be positive number, right? Okay. Now, these X-rays which are emitted, the energy of each photon, how do you write? H nu, H nu. Now, maximum, how much kinetic energy electron can lose? This much only, because this much it has while coming out. If I have 100 rupees, maximum I can lose 100 rupees. So if it has this much kinetic energy, maximum how much energy it can lose? This much only. And that will go into what? Maximum energy of photon. So H nu max will be equals to K. And K is equals to what I told? Q into V. So what will be the maximum frequency in the spectrum of X-rays? Why did I say spectrum? As I told, different frequency photons will be also there, because this is only the maximum kinetic energy that electron can lose when it hits the metal. By the way, did you notice one thing? This is like opposite of photoelectric effect, because in photoelectric effect, photons emitted electrons. Here electrons are emitting photons, right? So the maximum frequency in X-ray spectrum will be equals to EV by H. Now, if this is the maximum frequency, then there will be a minimum what? Wavelength. What will be that? So the minimum wavelength in the X-ray spectrum will be velocity by frequency. So if you divide by maximum frequency, you will get minimum wavelength. So that minimum wavelength will be C divided by nu max. What is nu max? EV by H. EV by H. H will go up. So one very, very important concept, all of you must remember that the minimum wavelength for X-rays is dependent on this accelerating voltage. Other things are constants, fundamental constants they are. H, C and E never changes. Therefore, it is inversely proportional to the tube voltage or accelerating voltage. So this is very important. Many questions will be asked based on this. Achha, this minimum wavelength also has one name. It is called cut-off wavelength. Cut-off wavelength. Okay. Now students, these X-rays which are emitted, if you pass them through something spectrometer, basically it will have some crystals, and it is called X-ray crystallography. So those crystals will act like prism for these X-rays. So different wavelengths will be separated. And then we will see the intensity, how many photons are falling in that photographic plate for different frequencies or different wavelengths. And that picture is what is called spectrum, right? So X-ray spectrum is very interesting. Let us try to see how it looks like. So X-ray spectrum, now if it was no visible to your eyes, it would have looked like this. It will be like full bright. The screen will be full bright. and at some particular regions it will be very bright. Okay, like that you would see if it was really visible. Otherwise, in photographic plate, when these X-rays will fall, they will create some dark regions. Some chemical reactions will change the color of those pigments, and therefore, wherever more X-rays are falling, that will become more dark. So you will see a more or less, continuous dark. Then somewhere at some particular regions, you will see very dark. That means, so this spectrum has two names. This is called your continuous spectrum. Continuous spectrum and continuous spectrum, X-ray spectrum. And these lines that you see here are called your line or characteristic spectrum. Characteristic, why we call? Do you know that in chemistry they say each atom has its own particular spectrum? Yes or no? Sodium has those two very popular yellow lines, sodium. So like that, every atom has its own spectrum. Okay, so if you know this line spectrum, so if you know the line spectrum, you will know which atom it is. So it is characteristic of the atom. Like signatures are characteristic of the person. Fingerprints are characteristic of a human being. Similarly, this line spectra are characteristic of the metal target which you are using. So depending on the target, this line spectra will have different frequencies. So this is called line or characteristic spectrum. So now this we have to plot in graph, because this way nobody will show you in textbooks. You can either plot with frequency or you can plot with wavelength. Let me show you with wavelength first. So this is intensity. For current I used what letter? Capital I used, no. Small I let me write. So this is intensity. Matlab how many photons are falling for that particular lambda. So this is like brightness and this is like color. So which color is more bright? That will be shown by this graph. The graph looks something like this. As you know, it has a minimum cutoff wavelength. So less than some wavelength, cutoff wavelength. Let me write lambda c. So this is your lambda minimum cutoff wavelength. So less than this, you will not have any emission of X-rays. So the graph will start from here only, and it has continuous like this something. So continuous nature it is. So this basically represents this this background which I have shown you, not the line spectrum. The continuous frequency. All frequencies are continuously present. So this is shown by that. This graph shows that. So this is your continuous spectrum. And here, as I told you, there will be some peaks. Some peaks. These peaks represent what? These high intense regions where there is lot of X-rays falling. So these are your high intense X-rays, which are your line spectrum. Okay, so people don't show this way, they show this way. What if you plot in intensity versus frequency? Then how it will look? It will have a maximum frequency above which you will not get any spectrum. Yes or no? And the graph will have a nature something like this. For high frequency also, low frequency also, then there will be some peaks. Can you see that I've interchanged the position of these two here? It should be right, because if this has more lambda, then corresponding to that lambda, this should have low frequency. Low frequency means it should be nearer to origin. Acha, by the way, this is for one particular voltage. meaning you have kept that apparatus, you remember, no, the device which I showed, which is used to create the X-rays, right? So there we have maintained some accelerating voltage. Based on that voltage, you will get one graph. X-rays will come out. Then you pass it through that spectrometer. It will separate the frequencies. So you will see, you can plot this graph, brightness versus wavelength or brightness versus frequency. Matlab, which frequency is more intense, that you have to show in this graph. Understood? Now, if I change the accelerating voltage, not the filament current I will not change now, only the accelerating voltage, then what will happen to this graph, do you think? It will go left, or do you think it will go right? This graph, not this graph. Kirtan, check the formula for lambda cutoff. Because what is the formula for lambda cutoff? HC by EV. So if you increase the voltage, the cutoff wavelength will decrease. Cutoff wavelength will decrease means the graph will come this side. And this lambdas, I will show you later, depends on, since it is characteristic spectrum, no, I told characteristic of the metal. So what do you think? It will depend on what? If it is characteristic of the atom, then it will depend on what do you think? Z. So these two lambdas depends on atomic number of the metal. So if you keep the atomic number, if you don't change the metal, these two will remain same. The location will remain same. But obviously, when you increase the voltage, electrons will have more energy. So they will create more higher energy photons. So the overall intensity will increase, but the graph will go left. Did you understand? So let us quickly understand why continuous spectrum is emitted. For that, we will use classical physics. Quantum physics will be too difficult for us right now. So why do we get continuous X-ray spectrum? Okay, so this is how people explain. So this is the nucleus of the target material, nucleus of atom in target. And when fast moving electrons are coming, fast moving electrons, do you think they will continue straight? See, the moment they come like this from infinity, let's say very far, this nucleus will attract them. So they will accelerate. Their direction of motion will change. Not only that, their speed will also change. So electrons' direction of motion and speed both will change. In fact, the speed will become less. And this process is called Bremsstrahlung. Bremsstrahlung. Spelling may be completely wrong. It is a German word for braking radiation. German word for braking radiation. From where radiation came, sir? Radiation, to you didn't tell only. Radiation came from where? Braking, to I hope you understood. Fast moving car suddenly turns, so it's like driver is applying brakes. Like that. Okay. So it's like skidding kind of thing. So during that acceleration, what Maxwell Baba told? I told, no, I will apply classical physics. So what Maxwell told, whenever charge accelerates or decelerates, what happens? It emits EM waves, right? And here the loss of energy is so much that the frequency of those radiation goes beyond ultraviolet. So this continuous loss of energy will emit continuous X-ray spectrum. So as this will decelerate, according to Maxwell, there is a formula called Larmore's formula, but we don't need to know all that. So as charge accelerates, it emits X-rays. And since it loses speed continuously, this X-rays also will have energy continuously. Right? If I lose energy continuously, you will gain energy continuously. And thus this X-rays will have continuous spectrum. So if they ask why continuous spectrum of X-ray happens? The simple answer is uh, due to acceleration of the electrons as it passes near the nucleus of the target. So this is your continuous spectrum. This is simple, nothing much to discuss. Now we have to go with characteristic line spectrum. Now line spectrum, you have to go to quantum mechanics. There is no other way. It's like how you got Balmer series, Lyman series. How did you get? Because of transition of electrons from higher energy levels to lower energy levels, you got line spectrum of Lyman, Balmer, Paschen, right? Visible, it was either visible or ultraviolet or infrared. But here the electrons are moving too fast, they lose lot of energy, so the frequency of photons go beyond ultraviolet, and atomic number is also high. That's why atomic number should be high. Why? Who remembers Rydberg formula? 1 by lambda. Acha, one thing you tell me, 1 by lambda has z square in the numerator or denominator? Are the one that you wrote is for hydrogen atom. For hydrogen atom we write like this. This is for hydrogen atom. This is for hydrogen atom, but for hydrogen like atom we have z square. So what happens when z is very large? If z is very large, lambda will be very small. If lambda is very small, frequency will be very high, and thus you will not get ultraviolet, you will go beyond ultraviolet if your atomic number is too big. So now we will study quickly the cause of line spectrum. Okay. So here what happens, imagine this is your nucleus of the target atom and it has this K shell, L shell, M shell, right? And many, because there are so many electrons, because we have chosen high atomic number element. So here 2, here 1, 2, 3, 4, 5, 6, 7, 8. Then here also there will be 18 electrons and so on, right? That formula, 2n square formula I gave you, right? In n equal to, depending on which shell, there will be how many electrons in that shell? 2n square. So now, when your electron from that tube will hit this target, there is a chance that that fast moving electron hits this electron, hits an inner orbit electron. So there is a chance that this fast moving electron coming from the Coolidge tube strikes and enters the material and goes deep inside and strikes some inner electrons. That is important, okay, inner electrons. So suppose this electron is ejected. Then what is created here now? Vacancy is created. So this electron comes and ejects one of the inner electrons. Okay. Once one of the inner electrons is ejected, from this outer orbits, this electron may make a transition like this. During that transition, it will emit a photon. Now these are inner orbits, remember. Inner orbits, do you remember, have very high energy gap? Yes or no? Inner orbits, if you remember for hydrogen atom, inner orbits have high energy gap. So this energy gap is too high. Plus atomic number of the element is also very high. So this frequency will be very large and this will be your X-ray photon. And since these photons will have specific frequency, they belong to line spectrum. So either this energy gap is possible or there is a possibility that electron from here can fall. From this orbit also it can fall. That will give rise to another X-ray with different frequency. So this is the reason why you get line spectrum. Okay. So just like for hydrogen atom we had Lyman, Balmer, Paschen, here we have something called K series. So K series means from higher orbits, from n2 equal to n to n1 equals to 1. So all these transitions will give frequencies which will belong to this K series. And from 2 to 1 is called K alpha line. K alpha line. Then 3 to 1 is called K beta line. If you know these two, it is enough. Then we have L series, where maybe electron in the first orbit is not removed, maybe electron in this orbit is removed, or once this electron goes to this orbit, higher electrons may again fall to this orbit, right? So there may be transitions from higher orbits to n1 equals to 2. Here obviously n is greater than 1. Here n should be greater than what? 2. And these transitions will also give photons, and that series is called your L series. Again, 3 to 2 is called L alpha, 3 to 2 is called L alpha, 4 to 2 is called L beta, and so on. But students, for our syllabus, only K series is there. Only K series is important. How to write wavelength for uh, characteristic spectrum, lambda for characteristic X-rays. So as I told you, this is your nucleus. We will discuss only for K alpha right now. If electron from n equal to 1 shell, which is your L, from here if one electron is removed, then when this second electron is going to fall here, look very carefully. For this electron, what charge it will see for this, what I should call this? Let's say this is some core. This is the core for this electron which is going to fall here. So for this electron which is going to fall here, how much charge it will see? Inside the nucleus, how much charge we have? Plus Ze, correct? And this one electron here is, actually it is a, in quantum mechanics you must have learned, it is spread, it is the electron has a probability distribution. So it's like a cloud, right? So there is this electron cloud of this electron. Remember, only one electron is here. So the total charge this electron will see will be plus Ze minus E for this core. This part you guys understood? Basically, this electron will screen the charge of one proton. This electron will shield the charge of one proton when this electron will see the inside, the core part. That can you feel little bit at least? For K series, not that Korean drama series I am talking about. For K series, because these electrons are going to fall here, for them, this is like a nucleus. For these electrons, this is like a nucleus whose atomic number is this. Therefore, for only K series, we can write 1 by lambda is equals to R. What was there in Rydberg formula? Z. Here what we will write? Z minus 1 square 1 by n1 square minus 1 by n2 square. And obviously for K series, n1 will be 1 and n2 will be 2, 3, 4 and so on. This is clear, students? This is the only formula we need. So this one is basically due to screening effect. This is due to screening effect. Now, for other series, it is not as simple as I explained. Okay, here, okay, it works. But for now, let's say I remove electron from here. This is your n equals to 2 orbit. There are how many electrons here? 7. 1, 2, 3, 4, 5, 6, 7. Now for these outer electrons in the third orbit, when they are going to come here, you may think like this, that for this series, for L series, why L series? Because K series means electrons are falling in first orbit. L series means electrons are falling in second orbit. So for second orbit, you may think it will be ZE minus 1, 2, 2 plus 7, 9. So 9E, but that is not how it is. Okay, we will write like this. So 1 by lambda is equals to R Z minus B whole square 1 by N1 square minus 1 by N2 square. This is for X rays. This will cover all the series. As I told, this B is called screening constant. And for our K series, it is approximately 1 actually, and for other series they will mention in exam if by chance they ask. If X-rays are coming out with wavelength lambda, then they will have some frequency also new. So this is frequency of X-ray photon. That frequency will be inversely proportional to wavelength. That means from this formula, for a given transition means from n, let's say from 2 to 1 or from 3 to 1, the frequency will be proportional to Z minus B whole square. Agree or not? Now this means root frequency will be proportional to Z minus B. That means root frequency will be equal to some other constant Z minus B. Do you know what is this law called? Anyone? Very good, Shabant. It is called Moseley's law. So it's nice to know Moseley's law, right? So if you plot here root frequency and you plot here atomic number, what kind of graph you will get? Y equal to mx minus c. So minus c means something like this, right? So this will be yours. The intercept should be negative and slope should be positive. So this is the graph, and this is why chemistry people before this, before Moseley's law, do you know that chemists used to distinguish elements based on mass number? But when Moseley discovered this, they saw, there is linear relation between frequency, which is characteristic of material. This was characteristic of material, and that is proportional to Z linearly. May not be directly proportional, but it's linear relation. So they thought it is better to distinguish elements not based on mass number but atomic number. So this was the contribution of Moseley. Intensity of X-ray from a Coolidge tube, capital I, this is intensity, from a Coolidge tube is plotted against wavelength, and the graph is something like this. This is your cutoff wavelength. This is the wavelength corresponding to your K alpha, and this is the wavelength corresponding to your K beta. So let me call this one as lambda, alpha, lambda, beta. So these two corresponds to your K alpha line and K beta line. I hope you remember. Those K alpha and K beta are due to electrons transition, and that will always give rise to line spectra. And I also hope you understood why alpha's graph is this side, because let me check that is correct or not. I think alpha should be this. Let us check. This is your n equals to 1, n equals to 2, n equals to 3. What I told, fast moving electron will remove inner electron first. let's say it removes electron from k orbit. Then when higher electrons will fall, you will get k series. K alpha was this line, K beta was this line. Which one will have higher frequency? This gap is 4, so K beta will have higher frequency. Higher frequency means lower wavelength. Lower wavelength means it should be this side, K beta. Correct only. Now see what they are asking. If the accelerating voltage is increased, okay, look here everyone. Why option A or B should be, these two cannot be correct. I told you characteristic or line spectrum, the wavelengths of the lambda of characteristic or line spectrum depends only on atomic number. Yes or no? So if you don't change the atomic number or the target, line spectrum will not change. So these two will be obviously wrong, because these two are wavelength of line spectrum. But they told voltage they have increased. So if voltage is increased, what happens to cutoff wavelength? Decrease. If cutoff wavelength, if this number decreases, this difference, if lambda c decreases means it goes this side, no, towards the origin. So if lambda c goes this side, this gap will increase. So the gap will increase. So if you subtract, there is a minus sign here. So if you subtract less and less, you will get more and more. So since the wavelength of the characteristic line spectrum will not change due to voltage, but cutoff wavelength will become less. So this gap between this coordinate and this coordinate will increase. So option A. K alpha wavelength emitted by an atom of atomic number Z equals to 11 is lambda. Find the atomic number. So we need to find atomic number for another element for K alpha only, whose wavelength is 4 lambda. So we know 1 by lambda formula is what? R Z minus 1 whole square 1 by n1 square minus 1 by n2 square. Now for K, both are K alpha. If both are K alpha, you know that n1 will be 1, n2 will be 2. So this is fixed. For both cases, this is fixed. R is fixed. That means 1 by lambda will be proportional to Z minus 1 whole square. By the way, why I wrote 1 and not B? Because this is K series. For K series, at least we know what is this constant B. So this is the formula we should use. That means lambda 1 by lambda 2 will be Z2 minus 1, Z1 minus 1 whole square. Ulta it will be, no, ulta. Inversely proportional, right? First lambda is lambda, second lambda is 4 lambda. Second atomic number they are asking. First atomic number is 11. Lambda lambda cancel, 1 by 4, z dash minus 1 by 10 whole square. Take square root, you will get z dash minus 1 by 10 is equals to 1 by 2. So z dash will be 21. Oh, not 21, sorry, 6. Correct, no? This 10 will go there, minus 1 will go there. 6 we will get, isn't it? If K alpha radiation of MO, MO is what? Molybdenum, okay. So K alpha again, first atomic number is 42, MO they are saying, I think it is molybdenum only, has wavelength 0.71 angstrom. Hey, this is same only. I will just put the numbers, you people calculate and tell me the answer, okay? They want wavelength for copper. For copper, what is atomic number? 29. Which series it is? Which line it is? K alpha only. So thank you. If both are K alpha, then you know that N1 will be 1, N2 will be 2. Remember, K beta they may say here. Then what will you do? Here you will write 2 to 1. Here you will write 3 to 1. And don't worry about screening constant, because if it is K series, screening constant is 1. So again students, same formula you apply. 1 by lambda will be proportional to Z minus 1 whole square. So lambda 1 by lambda 2 will be Z2 minus 1 by Z1 minus 1 whole square. First lambda is, let us write lambda only. Later we will substitute. Z2. What is Z2? Second atomic number is 29. So 29 minus 1, 28. 42 minus 1, 41 whole square. 0.71. Let us keep it angstrom only. Answer will come directly in angstrom. So if you cross multiply, lambda 2 will be 0.71 into 41 into 41 divided by 28 into 28. How much it will come? 1.52 it will come. Okay. 1.52. Let's do slightly different question. Find the atomic number. Matlab Z we have to find this time, which gives X-ray wavelength down to 1 angstrom. Down to 1 angstrom means this is the smallest lambda, the shortest lambda. R value they told us to take 1.1 into 10 power 7 per meter. Students, shortest lambda will come for what frequency? Maximum frequency. And maximum frequency will happen when the transition is from infinity to 1. Correct? From infinity to 1, maximum energy gap. So, infinity to 1 will be your maximum frequency, therefore your shortest lambda in the whole series. That's why they told down to 1 angstrom. Down to the minimum lambda, 1 angstrom. Also, what series it belongs to? Because we want maximum gap infinity to 1, obviously it is K series. So for K series, we can happily write R Z minus 1 whole square 1 by 1 square minus 1 by infinity square. This is 0, this is 1. So you will get 1 by lambda equal to R Z minus 1 square. So Z minus 1 square will be what? 1 by lambda R. So Z minus 1 will be, Z will be what? 1 by lambda R under root plus 1. Can you calculate, guys? Lambda is 1 angstrom. So 10 power minus 10 into R is 1.1 into 10 power 7 plus 1. So Z will come how much? Under root 1.1 into 10 power minus 3, which can be written 11 into 10 power minus 4 also. 10 power minus 4 plus 1. So this will become under root 10 power plus 4 by 11 plus 1. That will be 100, 10 power 4 square root will be 100 by under root 11 plus 1. Practice how much it will come. Energy you can do, no, for K alpha if they ask. What will you do? First lambda you find. After finding lambda, you find frequency, after finding frequency, find h nu, or directly write like this: energy, if they ask, h nu is hc by lambda. So lambda you try to write in nanometer because you know the value of h and c product. Okay. Highly energetic electrons are bombarded on a target of an element containing neutron number 30. So number of neutrons is 30. The ratio of nucleus of target to that of helium. They missed one small thing, students. Please write the ratio of size of nucleus or radius of nucleus. So radius of the target divided by radius of helium nucleus, this ratio is given to be 14 power 1 by 3. Frequency of K alpha line, frequency of K alpha line is given as 3RCB by 4. You have to find the value of this B. So frequency, how to find for any X-ray? We need to know from where to where it comes, because it is characteristic frequency, and K alpha means we know from 2 to 1, easy. Only thing is we need to know atomic number. Atomic number will come from here. How? In nucleus chapter, what we learned? The radius of nucleus is proportional to mass number power 1 by 3. So the radius of target divided by radius for helium will be equal to mass number of target by mass number of helium is 4. Target we don't know which element it is, but helium to we know mass number is 4, power 1 by 3. And they told this ratio is given 14 power 1 by 3. So mass number of target power 4 is power 1 by 3. So you can see both are power 1 by 3. So you can remove the powers. You will get 14 is equal to mass number of target by 4. So mass number of target will be 56. If mass number of target is 56, what will be atomic number of, we need atomic number. So tell me. So atomic number of target will be mass number minus neutron number, right? And 56 minus neutron number, how much they told? 30. So this is 26. So the whole game was to find atomic number first. Once we got atomic number, now we can find the frequency of K alpha line. So 1 by lambda for K alpha line will be R z minus 1 whole square 1 by 1 square minus 1 by 2 square. Isn't it? K alpha means from 2 to 1. So 1 by lambda will be R. Z, how much we found? 26. So this will be 25 this is 26. So this will be 25 square. This will be 4 LCM. 4 minus 1, 3. So 1 by lambda will be 625 R 3 by 4. What is there? 4 by 625 into 3R. So frequency is velocity by wavelength. So velocity substitute 4 3 into R into 625. So what is the answer? 3RC by 4. 3RC by 4. So this B must be 625, right? An X-ray tube is operating at voltage. So voltage is 50 kilovolt. Matlab 5000 volt. This is your accelerating voltage. I hope you remember the first discussion that we did. And 20 milliampere is the current. Current is equals to 20 milliampere. मतलब 20 into 10 power minus 3 ampere, which is 2 into 10 power minus 2 ampere. The target material of the target material has mass 1 kg and specific heat 495 joules per kg per degree Celsius. 1% of the supplied power is converted into X-rays. See, I told only 1% is correct, 50,000. One more zero. 1% only is converted into X-rays. So 99% goes into heat. 99% of input energy. Here input energy is the electrical energy, right? So then they are asking, mark the correct option. The rise of temperature of target is how much? Look carefully, they have not given you what is the rise of temperature. They want rise of temperature per second. Heat energy, heat given to target. To calculate rise in temperature, we need heat given. So heat given to target will be 99% of input, let's say heat energy given per second. That will be power given. Let me write in terms of power otherwise. So this is power given is 99% of input power. So power given to the target will be 99 by 100 of input power is I into V. So 99 by 100 into input power will be 2 into 10 power minus 2 into voltage. 5 into 10 to the power 1, 2, 3, 4. So this will 5 2s are 10, 1 0 cancel, 9.9 into 10 power 2 watt, which will be 990 joules per second. So this much heat is given to the metal target per second. Per second only we can calculate, guys, because they have given you only current and voltage. So we can calculate power only. So in time t, heat given will be power given into time. Power given is 990 into time. So this is the heat given, and from first PU, that heat given should be what? Mass into specific heat into change in temperature. So change in temperature per second. That's why this T is not given, because they want change in temperature per second. So you have to assume in 1 second. So bring this T this side, you will get 990 divided by ms. I think you can solve, students. Mass is given. I think 495 and 900 is easy calculation. Let me only do. How much it will come? 2, na? So 2 degrees Celsius per second. Anything else they ask in the same question? What will be lambda minimum? What was the formula for cutoff wavelength? Hc by EV. So put the values and get the answer. Let me not waste time. You can try once. Voltage was given how much? 50 kilovolt. So 5 into 10 power 5. 5 into 10 power 4. So do this calculation and check the answer is how much. Okay, students, now this C and D option is also important. The target should have high melting point or low melting point. Target should have high melting point. But in this question they told it should have, must have high low. What is high low? By mistake. They should ask high or low. So answer is high melting point. Also they told it should have low thermal conductivity. No, it should have high thermal conductivity. Thermal conductivity we will do during revision. but I hope you know that if conductivity is more, heat will be dissipated more faster. That is what you want. No, you don't want it to get too hot. So you want the material to lose heat easily. So you want it to have good conductivity. Penetrating power of X-rays. So penetrating power of X-rays depends on number one, filament current. Number two, this is question, okay? This is option A, B, applied voltage, target, all of above. What do you think? All of above. What do you think? Yeah. So the answer is penetrating power of X-rays depends only on applied voltage. Okay, this is something you must know. Very good, Anish. Because when you increase the voltage, you increase the kinetic energy of electrons, and that makes X-rays of high energy. That creates X-rays of higher energy, and they can penetrate more. Penetrate more. Those X-rays which can penetrate more, they are called hard X-rays. Hard. And those which cannot penetrate more are called soft X-rays. So soft X-rays means you can think low voltage. So soft X-rays, if they mention, then you have to think of low applied voltage. Okay. Same question, I'm going to replace penetrating power by intensity of X-rays, overall intensity. Intensity of X-rays depends on what? Intensity of X-rays depends on all of them. Depends on all of them. Okay, so try to remember that. Very good, Kirtan. So if you increase filament current, then it means more electrons will come out. More electrons will come out means more photons of X-rays will come out. So overall intensity will increase. Voltage will increase means energy of X-rays will increase. So overall intensity will increase. Atomic number also, that 1 by lambda, if you remember, the characteristic lambda will decrease. So again frequency will increase, again intensity will increase. So please remember, intensity of X-rays will depend on all these three factors. The next question is, there is an X-ray tube, and it has filament current I, and distance between anode and cathode. Distance, this distance is given as D, and applied voltage is given as V. And they are getting some characteristic spectrum. They have not drawn the graph, but they told in the question they are getting continuous and characteristic X-rays, which looks something like this. You already know, right? Now they are saying, if after this they are saying, if current is reduced to half and voltage is increased to 2V and distance is reduced to D by 2, then how things will be affected? Okay, first option says cutoff wavelength will reduce to half and wavelength of characteristic X-ray will remain same. Now first you tell me, since Z did not change, target is same only. target is same, matlab atomic number is same, Z is same. So if target is same, characteristic wavelength will not change. Characteristic wavelength will not change. Will not change. So that part of option A is correct. But they told cutoff wavelength will reduce to half. That is also correct because cutoff wavelength is inversely proportional to voltage. So if voltage increases 2 times, cutoff wavelength will become half times. So option A is very much correct. Yes or no? Second option is saying cutoff wavelength as well as wavelength of they are saying cutoff wavelength will remain same, so no need to tick that one. Option C is saying cutoff wavelength will reduce to half. That is correct. And intensity of all X-rays will decrease. Intensity of all X-rays will decrease. This is what JEE Advanced has given as right option in their official website. And it is clearly wrong to say intensity of all the wavelength will decrease, we cannot say. Why? Because you have increased voltage also, right? If voltage was kept same and filament current was decreased, if filament current was decreased, number of electrons reaching the target will decrease and therefore less number of photons will come. So intensity of X-rays for all the wavelength will decrease, no doubt. But here voltage you have increased. So if you increase only voltage, the graph will shift left side, I told, and it will become like this, I told. Yes or no? If you increase only voltage, graph will shift left side because wavelength has to become half. Also, intensity of all the lambda or each lambda, for every lambda, the intensity will increase. Correct. So this would be right if only voltage was increased. But they decrease intensity. So now when they decrease the intensity, it may be something like, I will try to show you. So this is dot dot 1. One may be like this, and other one, it should have increased overall, but current they have decreased, so the graph will also come down also, shift here also. So if you shift here and come down, it may become something like, something like this. So we cannot be sure that for every lambda, the wavelength will decrease. You can see here for this lambda, dot dot was here, the solid line is here, so intensity has increased. Here dot dot was here, but solid line is here, so intensity has decreased. So therefore that option is not actually correct. So the only option correct is the first option. So please try to, and this will have no effect, distance will have no effect, because normally these distance are too small, and by changing the distance you will change the electric field, right? Electric field between cathode and anode, that electric field was what? V by D. But V will be what? E into D. So if D becomes D by 2, electric field will become 2 into E, because voltage is constant, which is controlled by the battery. So electric field will change, but that will not change anything in X-ray, because voltage controls what is the energy of the electron by the time it comes out. So basically what happens is, if you give it less distance, then electron will feel more force because of more electric field. So work done will be same. Got the idea? Distance is small, but electric field is more, so work done overall will be same.